Others joining us here while we get started. But thanks everyone for joining. This is the third time we're going through this. So if you're wondering where everyone is, we've already had two of these. So this is you guys are getting to see the really refined version of this webinar. So we're going to be talking today about applying full bed masonry to six-story wood frame. Now we just say six-story wood frame because that's what the building code allows us to go up to, but this is really a construction practice for everything over 3 stories wood frame to apply masonry. So just basically what you need to know. We're not going to get super technical. The whole point of this webinar is to give our industry stakeholders, sales teams, and anyone who's interested in this information just some general overviews as to what you can talk about when we're addressing this type of building. Hold on, I'm just having a computer issue here. There we go. So what you need to know, full bed depth masonry units can be used on wood frame buildings over 3 stories. Our building code changed in 2015 to allow for this to happen. And we've since been figuring out ways to get masonry onto these buildings. And now it's 3 stories to a maximum of 6 stories. There is a lot of misconception out there that we've been finding among some of the architects and engineers that this can't be done. So if you do run into that when you're trying to sell the masonry product for a building like this, we don't get fooled by people telling you it can't be done. It can be done. So in this presentation, we're going to go over the brick ledge considerations that you need to know, shelf angle considerations that you may need to know, tie design, differential movement with clay masonry units, differential movement with concrete masonry units, and that's it. So we'll start off with brick ledge considerations. So depending on what part of the country you're in, you may or may not see this as a common construction practice in your area. I know here in Ontario, we use brick ledges quite a lot. That's kind of the common practice. And obviously you can see here is a picture of a brick ledge, and that's right at the foundation there. I know in Western Canada, that's not so much of a common practice. It's more shelf angles at the foundation, but we'll talk about that. We'll talk about that as we go through the presentation as well. So, and if anyone has any questions throughout the presentation, please feel free to either jump in and ask or ask it in the chat. I think Nicole Miller from the Alberta Masonry Council is on board here, and she can help answer some of the questions as well. So the brick ledge consideration. So if there is a brick ledge on one of these buildings, the brick ledge can actually support the first 3 stories, so up to 11 meters. All right, so you don't need to put any shelf angles on, just as if you were building a normal wood frame home. For the first 3 stories can sit on the brick ledge. Anything after the top of the 3rd story, so if you're going up to the 4th, 5th, and 6th floors, you would need to put a brick ledge in there, sorry, a shelf angle in there, and we'll get to that as the presentation goes through. But just as a consideration here, the brick ledge can support 3 stories of brick, the first 3 stories of brick. So this is important because obviously shelf angles can be pretty costly, and they oftentimes involve various trades to come in to install them. So the less we have to use a shelf angle, the better. So that brings us into shelf angle considerations. So you can see there's a shelf angle there. So if there is no concrete brick ledge, masonry can be supported by the shelf angle at the foundation level. So if you can see the drawing there, the shelf angle is actually anchored in to the concrete foundation, and then it goes up. So this method is used. If this method is used, a shelf angle is required at each story above the 3rd to support the masonry load and isolate differential movement. The good thing about this method is it allows for continuous insulation below below grade, so below the foundation, and allows it to come through. So depending again on what part of the country you're in and the energy codes that you are subject to in that part of the country, this may be the method that you have to use to get the NECB 2017 specifications to work. With a brick ledge, unfortunately, concrete brick ledge on the foundation, unfortunately, we don't have a way to have continuous insulation through that. But in Ontario here, we're still on the NECB 2011. So we don't have to worry about that, at least in the status quo, but we know that's going to be changing. So if you are watching from Ontario, make sure that you are paying attention to the shelf angle of the foundation, because that could be coming down the pipe pretty soon. So the continuous insulation of the foundation kind of looks like this. I've got a clearer one here. So this is continuous insulation at the foundation with a shelf angle and it's consistent with NECB 2011. So the only difference between the NECB 2011 and the 2017 drawing is that insulation actually would continue below the foundation and below the shelf angle there. So having that shelf angle obviously allows that to happen. So that's, I know out in Alberta, that's how they're going to be building on a go forward basis. Okay, so we'll go into the shelf angle considerations with a brick ledge. So if you are going off of a brick ledge, the first 3 stories don't have to be supported by anything other than that brick ledge. So this drawing here is actually meant to show movement joints, but you can see the one green line that's running parallel to the ground. There is it's where the shelf angle would be. So above the 3rd story, a shelf angle would be placed in there, and then we'll get into movement joints later on in the presentation. But you can see here that the shelf angle would be at the top of the 3rd story, supporting the 4th story. And then obviously after that, every floor up to the 6th floor, to the maximum height you can go, requires a shelf angle. So the spacing of the joints does change a little bit after that, but we'll get into that. But just keep in mind, if there is a brick ledge, you can go the first 3 stories. So if a brick ledge is being used, the first 3 stories of masonry may be supported off of that ledge. Every story above the 3rd requires a shelf angle. So just a recap there, but you can see here, this is a little bit how the drawing should look for a shelf angle on the supporting the 4th floor. So you can see in this drawing that it's a through bolt supporting the shelf angle there. So we are currently looking into whether or not a lag screw can be used instead of a through bolt for a couple of reasons. Obviously, using a through bolt involves the mason going inside to put that bolt through. Also, that does create a pretty substantial thermal bridge, whereas a lag screw going into the wood there wouldn't create there would be a bit more of a thermal break, which would be better, obviously, for energy requirements that we're going to be seeing coming. So we are doing that testing. The Masonry Works, the Alberta Masonry Council, and the Clay Brick Association Canada is doing testing on the strength and thermal properties of both a lag screw and a through bolt. So maybe that's going to be another webinar series once we get that research done. We are in the first stages of it now. However, obviously, given everything that's going on, a lot of the research at the universities has been slowed down substantially. So here's just what it would look like with the cavity insulation. So brick on wood with the cavity insulation, you can see each of the details here, and that's with a wood backup as well. So, and if you guys are interested in obtaining these details, we can send out this presentation after. Just send an email to info@masonryworks.ca, and we'll get you the presentation. Also, all of these drawings are available on the Alberta Masonry Council website. So they are there for you to access. And obviously, if you guys need any sort of help or support when talking about this type of construction, we're here to help as well. So tie design. So obviously this is a very important thing to consider, mostly because of differential movement, but there is also a difference in rigidity between wood backup and wall masonry. Can I just ask everyone to throw themselves on mute if you're not talking? I'm getting a little bit of background here. So perfect, thank you. So yeah, there's a difference in rigidity between wood backup and wall masonry as well. So we'll talk here a little bit about the tie design, the tie spacing, a little bit about the properties of wood, why it moves the way it does, and same with clay brick and concrete masonry units for the exterior. So this would be your typical tie spacing for an SPF wood stud wall. So you can see it here. Again, these diagrams, these drawings are available on the Alberta Masonry Council website. So tie selection will vary varies dependent on the type of masonry used on the exterior. So clay brick, there's certain considerations that need to be taken in place versus concrete masonry. So concrete brick, split face or architectural block. Now the tie selection itself doesn't really change, but the way that the tie itself works does vary dependent on the exterior cladding that you're putting on. So we'll talk a little bit about differential movement. So it occurs obviously when independent structural components are joined at different parts of the building. So prescriptive building code provisions have evolved and provide more generous height limits for veneer construction over wood frame. So the 2015 building code allows us to go 6 stories now. So the use of brick veneer over wood frame construction on buildings of 3 to 4 stories is now in compliance, obviously up to 6 as well. So with veneer heights often exceeding 40 feet. So specifiers should keep in mind these types of structures require special attention and detailing to avoid problems that are caused by vertical movement between clay brick and wood frame. So we'll get into that. So for clay brick itself expands and increases in dimension while the wood frame shrinks and decreases in size. So to account for this differential movement, the tie selection is important, and we recommend, or we are saying that you have to use slotted ties for to account for this movement. So we can see here that each floor, the clay brick will expand. So you can see on 4 floors there, it expands almost a quarter of an inch. So wood itself shrinks. So Canadian Wood Council shrinkage calculation here, and this can all be accessed at the Canadian Wood Council site. There is a calculator there, but we can see here that the shrinkage for wood over 4 floors is over an inch. So you've got the brick expanding and the wood shrinking by more than an inch, which is obviously going to cause substantial differential movement. So that's why the tie is important. So, and then obviously on six stories, the wood shrinks even more. So it's over an inch and a half on 6 stories. So just knowing this and taking this into consideration when these buildings are being specified is really important for the detailing, so our masonry wall system doesn't fail. So wood moisture and shrinkage. So the wood contains a trace of moisture, which plays a key part in determining how strong and how dense the wood is. Even the most highly treated wood still retains moisture, and exposure to heat, as well as changes in the moisture content of the surrounding environment, can prompt adverse reactions that precipitate shrinkage. So obviously this is dependent on the climate that you're in. Obviously the Ontario climate, for example, is a little bit more humid than the Alberta climate here in Canada. Alberta is really dry. Same with like British Columbia is quite moist as well. So these wood reacts differently in different climate zones, but we know that it still has to be accounted for. So Timber itself is what's known as hygroscopic, so that means it absorbs water. Obviously, a tree is a plant and it wants to absorb water, so it continues to do that even once it's in your wall. So timber exposed to an excessively dry or cold climate can release exorbitant amounts of moisture, leading to shrinkage. So wood prefers dry conditions. So when the temperature is between 0 and 40 degrees Celsius, and the wood moisture content remains high for an extended period of time, wood will start to get moldy. That's just something that we know, and we've seen a lot of cases of that, particularly in Western Canada, where they started building with wood a little bit sooner than we have out here in the East. So once the relative humidity exceeds 90% under these conditions, wood will start to rot. However, obviously in sub-zero temperatures, even a high humidity won't be a problem because it's too cold for mold and fungus to grow. Given that there's such risk factors with wood and moisture itself, brick is a good option for managing this moisture on these frame buildings. The combination of materials can make for safe and durable buildings if the property or the building is detailed properly. Now, obviously, if we're comparing it to a stucco application, we know that the stucco application is virtually right up against the wood frame. So if any moisture gets in there, oftentimes we will see the wood start to rot, whereas obviously the separation from the brick veneer to the backup wall helps manage that moisture, right? Oftentimes water doesn't jump even if it's getting in there. So this leads us to a masonry tie selection for concrete masonry. So concrete masonry, such as split face architectural concrete or concrete block, does shrink over time. However, the wood frame shrinkage is greater than the shrinkage that we'll see in a concrete masonry unit on the exterior. So we still need to account for differential movement. So we can see here that the shrinkage of a concrete block on an exterior wall is about at 4 stories is about 0.192 inches, and obviously that increases as we add more floors on top of that. Now, if you remember from a couple slides ago, the shrinkage on a 4-story wood frame is over an inch. So that differential movement will still be there because the wood will shrink a lot more than the concrete masonry unit. So your tie options are the ones that we know of that are on the market right here are the adjustable block V-tie and the adjustable ferro V-tie. Either one of those will do the job. So just in terms of movement joints, so to manage differential movement, the appropriate size and spacing is important, very important, particularly with the amount of movement that we'll be seeing. The movement joint specifications will vary dependent on the number of shelf angles used and whether or not you've got a brick ledge at the foundation. So you can see here, this is brick bearing on the foundation with a shelf angle at the top of the 3rd floor. So we've already seen this picture here, but you can see where the movement joints would go in, right? So at the shelf angle above the 3rd floor, and then obviously you've got your vertical joints there as well. So here's a little bit of how it will work, and I can just slide over to here. So if this is off the foundation, the movement joints for windows are as follows. So on the 1st floor, it's 3.35 millimeters. 2nd floor, 10.1 millimeters. 3rd floor, 16.8 millimeters, right? So then the shelf angle goes in. The shelf angle at the top of the 3rd floor would have to have spacing of 20.1 millimeters. Every shelf angle after that, though, would be 6.7 millimeters at each floor thereafter. Now, 6.7 millimeters is the minimum that spacing joint has to be. Generally, common practice is to go 10 millimeters, and that's fine too, just as long as the compressive material is put in there properly. And then with the windows, once you get above the shelf angle, because that differential movement is isolated to each floor, the windows, the joints there would be 3.35 millimeters. So if you're putting on a shelf angle at each floor, as you can see here, where the shelf angles would be, it's a little bit less complicated. It's a little bit more uniform. So there's the drawing there, but you can see the shelf angle, the minimum spacing is 6.7 millimeters now. Obviously, it's generally going to be specified as 10, which is fine. And then the windows are 3.55 millimeters. So because the movement is isolated by the shelf angle at each floor, that's why you just remain consistent on the spacing of the movement joints. So some additional resources. So if there's, if you want to go and access some of this information, we do have technical aids available on our website with some more of the engineering behind this and how it works. So our site, masonryworks.ca, the technical aids are posted there. The Alberta Masonry Council also has it, along with a lot of the drawings that we saw in this presentation. Obviously the dimensional calculators from the Canadian Wood Council, and then just information on ties, you can go to strongtie.com. And they've got all the calculations for wood shrinkage. So just some acknowledgements here. I'd like to acknowledge the Alberta Masonry Council. Dr. Mark Hagel and Nicole Miller helped us in collaboration with us put together the technical aids that really got the ball rolling on this, and they've helped us a lot throughout this this presentation. David Moses from Moses Structural Engineers, the Canadian Wood Council, Robert Jonkman, and Conroy Murray at Masonry Works. So at this point, I'll open it up to any questions. I know I did see the chat bubble popping up here while I was talking, but if there are any questions at this point, I think Nicole and I would be happy to try and answer them. Is there any questions?
Andrew, it's Mike here in Edmonton. Hey,
how are you?
Good, buddy. Question: do you guys recommend Type N on something that tall?
I think Nicole might be better off to answer that one. We didn't really get too much into the mortar type. Nicole, do you have an answer for that? If she's online, I can get you that answer as well. It's not something that we've really taken into consideration through this. So, but I think the type N would be sufficient, but I don't want to give you wrong information here.
That's a great question, Mike. As you know, we have our mortar recommendations. We really go into depth with that for adhered stone. However, in this case, you are having your full bed brick, and then you are having that broken up. You're not really going super tall in considerations when you're thinking of it. When you're having it broken up by shelf angle, you're almost mitigating it story by story.
Yeah, I was just curious because I had a guy from ACI Architects actually call me on this exact thing yesterday. So he said either Type S or Type N. I said I recommended Type N because it helps a little less cracking, right? If there is any movement. So
that's a good point. I mean, Type S is usually kind of like your structural mortar, but then you are having that cracking. So. We also have found out that from mason to mason, it kind of differs on what their experience is for what they're using. But we do have mortar recommendation tables. So I'll pop in my email into the chat, and anyone that's on the phone call, please reach out to me and I can send you that table, and that's based on our AMC testing program.
Perfect. Thanks, Nicole. Any other questions here? Last chance if you have any questions. All right, well, given that, I'd like to thank everyone for hopping on here today. It was a good presentation. I liked the few questions that we did get. I saw the chat was pretty populated as well, so that's good to see. So thanks everyone for hopping on. And like I said, if you have any questions, any of the resources that we've provided you within the chat are there. And also you can either email Nicole or myself or Masonry Works in general at info@masonryworks.ca. And we're gonna continue developing some of these webinars aimed at sales staff and kind of high level stuff, not super technical, to keep you guys busy during COVID here. So thanks everyone, and I hope everyone's staying safe and starting to enjoy this nice weather that we're starting to get.